Lesson 56, 9.4, adding and subtracting rational expressions with unlike denominators. The steps will help you out, but basically what you'll need to do is find that least common denominator that we've worked with here the last couple days. Two ways to find that least common denominator, one being the L method, or you can use the prime factorization method. Once you find the least common denominator, you would do just as you would normal fractions. You need to write each rational expression as an equivalent expression with the same denominator. Once you have the same common denominator, you would add and subtract your numerators, write that over your common denominator, and then finally simplify your rational expression. Looking at example 9, denominators are different. We need to find that common denominator. Actually, before I would do anything on this problem, one thing that I would do is go ahead and simplify within your problem. Look at this first fraction here. I'm able to take out an x on each fraction. So I'd have 6 over 5xy. Look at your second fraction. Also able to take out an x. So I was able to simplify right away. Now, take your two denominators, your 5xy and 3y squared. In this case, I'm using the L method. I see that I can factor out a y. When I factor out a y, I'm left with 5x and 3y. Take everything on the outside, multiply it to find your least common denominator. In this case, 15xy squared. So here would be your problem. What you need to do is get that. How would you get this equivalent, this 5xy equivalent to 15xy squared? Well, I need to multiply by 3y. Same concept over here, 3y squared, need to make it a 15xy squared, so I need to multiply by 5x. When doing so, 3y times 6 would give me the 18. The 5 times the 5x would be 25x. I write that all over my common denominator, which is 15xy squared. Looking at this problem, this cannot be simplified anymore. So in example 9, this would be our answer. At any point in this video, remember you're able to go ahead and pause if you need to catch up. So we're going to jump right down to question or example number 10. Example 10, we have no denominator over here. So the least common denominator is going to be 6x squared y squared. Here's that original equation. I just made this a fraction. In order to get that fraction or the denominator, I need to multiply by 6x squared y squared. When I do that, I take my 4y, basically multiply it by 6x squared y squared, and I come up with 24x squared y cubed. And in the second one, I still have plus 5y. I also could have actually factored out a y right away. I didn't catch that. So if you didn't catch it, that's all right. You're going to have to do a little more legwork in the end. So looking at this, I note that I can factor out a y out of each term. So when I factor the y out, I'm left with 24x squared y squared plus 5. Now I have a y in that numerator, and I have two y's down here in the denominator. So I can actually cancel a y out. And if I would have done that in the beginning, it would have saved me a little math here. So I wind up with 24x squared y squared plus 5 all over 6x squared y. Example 11, common denominator 3b minus 2. Here's my original equation. To get 3b minus 2, I need to multiply this fraction here by 3. And the fraction over here, I need to multiply by b minus 2. Now what I did is I went ahead and I rewrote this here. I did my multiplication. 3 times 2 is 6. Now, this is the trick. This is the curve. This negative sign basically gets distributed into the 4. So really what you're doing is you're distributing a negative 4 into your b minus 2. When I distribute, negative 4 times b is that negative 4b. Negative 4 times negative 2 is that positive 8. So here's my numerator. Here's my common denominator. I look at my numerator and I can combine like terms, in this case 6 and 8. And I would wind up with negative 4b plus 14 all over 3 parentheses b minus 2. Now, a lot of people look at this and say, well, you can factor a 2 or a negative 2 out. Yes, you can factor that negative 2 or 2 out, giving you a different binomial. But that 2 that you factor out, you're not going to be able to simplify it anymore because there's a 3 right here. So either way you look at it, either would be an acceptable answer here. Example 12, least common denominator, a plus 4 and a plus 6. We have the original fraction. This fraction here I need to multiply by a plus 6. And the fraction here I need to multiply by a plus 4. Again, what I did in this next step is I just went ahead and rewrote it. So I had 4a, and I'm multiplying that by a plus 6. I have that negative 5 that I'm multiplying into a plus 4. And I just wrote it over my common denominator. When I did it my distributive property, I multiplied 4a into a, which is 4a squared. 4a into 6 is 24a. Multiplied my negative 5 into a, I get negative 5a. And multiplied my negative 5 into a positive 4, which would give me negative 20. Now I can combine my like terms in my numerator. In this case, the 24a minus 5a. And in example 12, we would be left with 4a squared plus 19a minus 20 all over a plus 4 and a plus 6. Example 13, least common denominator is m squared minus 1. Remember, m squared minus 1 is basically saying m plus 1 and m minus 1. So here's that original rational expression that I have here. I just wrote 6 over 1. I need that common denominator, so I need to multiply by m squared minus 1. When I do that, I have 6 times m squared minus 1, so my distributive property is happening here again. Following my distribution, I'm left with 6m squared minus 6 minus 6m all over m squared minus 1. In this next step, I wanted to be sure that basically I put it in as m plus 1 and m minus 1. When I factored out my 6, I'm left with m squared minus m minus 1. Now, the reason why I factored out a 6 here is to make sure that when I have this trinomial in my set of parentheses here, I wanted to be sure that I was not able to factor it down into 2 binomials. Okay, you see that minus, minus, that's normally that plus minus in your binomial. And I can't factor it down into 2 binomials. I wanted to make sure that I couldn't factor it into 2 binomials, because if I was able to, I might have potentially been able to reduce or take out one of these binomials off your numerator and denominator. But I wasn't able to, so this is where I'd wind up with my answer. Question 14. The first thing that I did here is I looked at my denominator here, and I took my trinomial and I factored it. I like to factor that right away. Again, just like in example 13, the reason why I factored that is to make sure that I was not able to simplify. And I have a p plus 2, so I'm not able to simplify. So my least common denominator is 4p squared, p plus 4, and p minus 3. In my original equation, I have the 3 minus p plus 2. What I did right now is basically what's going to happen here is you need to factor, or I should say, you need to distribute this negative sign into the binomial here. So that's what I did in the first step. And then I'd wind up with 3 over 4p squared plus negative p minus 2 all over p plus 4 p minus 3. And I just use this in factored form. Next thing is I'm actually going to use my least common denominator. So what I had to do is take this p squared plus p minus 12, and I needed to bring it to this side here. It's easier to take this trinomial and multiply it versus taking the two factored ones. But it's nice to know the factored form for reducing. So I took my numerator, 3, and distributed it into this p squared plus p minus 12 to get my least common denominator. And on this side, I need to multiply by the 4p squared. So I'm taking my 4p squared into my negative p minus 2. I get that common denominator, which is 4p squared all over p plus 4p minus 3. In this step here, I distributed my 3 into p squared plus p minus 12, so I wound up with 3p squared plus 3p minus 36. And I distributed my 4p squared into this binomial here, and I wound up with negative 4p cubed minus 8p squared. And again, that's all over my least common denominator. Now I looked at my numerator and I was able to combine like terms. In this case, a positive 3p squared and a negative 8p squared. So when I combine in my like terms, I have negative 4p cubed minus 5p squared plus 3p minus 36 all over my least common denominator. This concludes lesson 56, 9-4, adding and subtracting unlike denominators.